Roll number 191016. So this is our lab 3 example number 1, and in this we have to send the value from 00 in hexadecimal up to 0xFF in inside port B. So first we will start from this header, that is hashtag include avr slash io.h, that is for writing our C programming. Otherwise our programming would give error because it would not understand that. Then we have defined the speed of the FCPU as because this is defined because we want to set the speed of our delay, and which is written below here as hashtag include util slash delay.h. And inside main function we have first declared a character z, then we have set our direction of port B as 0xFF, and then we have applied a for loop, and we have already initialized the character z, so z is then initialized as 0, and it is then we have applied a condition that it should run from less than equal to 255, and until that it will be incremented. And then we have given a delay, and this is a while loop, and a return 0 function. It actually does nothing, and I've already debugged my program, so let's go towards our Proteus simulation. So here we can see when I turn on my simulation, these are our these are our pins of port B, and uh, I should restart. When I've restarted this, you can see that these are continuously blinking. But what if I didn't put a delay in that? Then it would be a static, just it wouldn't be blinking like this is, like it would be a static, it would be static. So now it is showing that there is a loop, that it is going from 0 to up to 255. So that was our example 7.1. Thank you. Roll number 191016, example 7.2, lab number 3. Inside this we have to send some ASCII characters inside port B. So these are our three header files which we have already discussed in say example 7.1. Now we will carry out our procedure explanation towards the main function, and inside our main function we have declared an unsigned character my list, and inside my list we have given the data as 0 1 2 3 4 5 a b c d, and we have declared another unsigned character as unsigned character z. Then we have set the direction of port B, and then we have applied a for loop, and inside for loop for this character z we have initialized as z is equal to 0. The condition is z should run for less than 10, and until then it should be incremented, and for that it should store the value inside my list, and this whole should be stored inside port B. So now we will debug this. And here we can see that it has been debugged with no error. So inside our Proteus we will load the hex file, inside our hex file, here we can see that first it will only blink two LEDs, then oh, I'm sorry, I haven't given any delay here. So now we will again debug this, and now we will see on the Proteus that what are our results. So it was so fast that here we can say that only in a blink of a second. So you can increase your delay for that to check all of your results. So this was our example number 2. Assalamu alaikum, roll number 191016. This is our lab 3, example number 7.3. Inside this we have to show we have to toggle our ports from 0 to 200 and display it on the port B. So as we know that these are our headers that define our body, and inside the main function we have given the direction to the port B as 0xFF, and inside port B we have given the value as 0xAA, or in binary we can see as 10101010, and then we have initialized an unsigned character Z for, and then a for loop is being applied in which this unsigned character Z is initialized as 0. The condition is that Z should be less than 200, and up till then it will be incremented, and inside the for loop the main condition is that port B should be toggled up till this condition is being fulfilled, and a delay is being applied of 1500 millisecond. And this was our AVR code. I have already debugged it, and now we will continue our simulation towards the Proteus part. This is our Proteus part. Here we can see that the ports, the LEDs are constantly blinking, means the ports, the pins inside the ports are constantly being toggled, because first it was like 1010 1010, and then after 1.5 second it becomes 0101 0101. So that was all, and its hardware simulation is being shown.
और ये अल्ट्रेशन अभी चल रही है।
जैसे कि आपने अल्ट्रेशन में देखा हुआ कि सपोज़ हमारे पास अगर ए था तो वो 1010 पे जाएगा, उसके बाद जो नेक्स्ट अल्ट्रेशन होगी वो होगी 0101। चूँकि ये डिले थोड़ा कम है हमारा, इस वजह से ये इतना तेज़ शो कर रहा है, क्योंकि हमारा CPU जो हमें टोटल स्पीड देता है वो कोई फ्रीक्वेंसी जो होती है उस
Assalamu alaikum, I'm Shah Abdullah from Mechatronics department, roll number 191016, section A, and today we will discuss about the example of lab 3, that was example 7.10, and in that it states that we have to send a byte of data from port B to port C. So first of all, here we can see we have included all the libraries that are necessary in AVRC programming. The first one is for AVR programming, and we have defined the CPU speed for the delay function, and the delay library has been used. And then we will continue towards our main function, and inside main function we have first declared an unsigned character named temp, and then we have set the direction of pin B and port C, and then we have used a while loop, and inside while loop that we have the unsigned character that we have declared here, we have made it equal to our pin B that we have set its direction here. And inside port C, that means in this temp the byte of data has been stored, and then ports inside this port C, the data that was being stored in temp is being stored. And then we have used a delay function, and that was our program. And now we will debug it. I've stopped, and now we will again debug it. It has been successful. So now we will continue towards our Proteus simulation. So first of all, we will click on our Arduino, and then we will go towards our hex file, and that hex file is present wherever you have saved your ATMEL Studios folder. And now we can see that the simulation is on, but why the LEDs are not blinking? Because we have sent the data from pin B, that was 0x00. So that was and we have sent it to port C. Here we can see these are the pins of our port C. I have used only 4 LEDs. Here we can see that it is showing no blinking on the LEDs because we have sent 0x00 from the pin B to port C using intermediate using the unsigned character temp as an intermediate. So that was our example 7.10, and next will be its hardware simulation. So as we can see in the hardware, the port C is blinking no LED, so hence it verifies our results. Roll number 191016. This is our lab 3 example number 7.12, in which this code was given to us, and it stated that we have to manipulate and find the results. So first we have set the directions of the ports, 3 ports that are A, B and C. Then we have performed several operations in port B, C, A and port B again. So in port C, AND operation is performed between 2 hexadecimals, and I will directly tell you that answer in binary, that is 0101. And in port C, this OR operations gives us in the least 4 bits 1100, and the first 4 bits it gives us 1100, and in port A it gives us this is an exclusive OR operation, so the first 4 bits gives us the value of 1100, and the last port B, it's a negation, a NOT gate is applied to 0x55, so it will give us if we can see that 5 in binary is uh, 0101, so it will give us 1010. Now let's check that in Proteus. So this was our Proteus. Let me stop that, and uh, now if we can see, this is the first port B binary operation performed. So as I told you earlier, our result was 0101, and then at port C our result was double zero and double one, and then at port A the double zero double one. Here if we start from here, then we can state it as double one double zero and double one double zero, otherwise double zero double one. And similarly at the negation we performed, we can see the above port B and this port B. uh, we will see that that 0101 was performed as negation, so here 10 and 10 is our solution. So now we will carry on towards our practical hardware work. Here I am showing only these 8 LEDs, and these are performing the function of port B and negation of that, and the negation of the value that we used in port B again. So this is our negation, and here we can see that only uh, this LED and this LED is blinking. That means 10 and 10 is blinking. And now if we see towards this port, so here 0 1 0 1 is our answer. So this is our port B, the AND operation one, and this one is our negation not operation. So that was all for this example.
Assalamu alaikum. I am Shah Abdullah, and the recorder is SAHIBZADA 191016. This is the C code of the first task, that was to display 7 segment and from 0 to 99 counter. This is our code, these are our libraries, and inside B port we have set the direction, and inside C port we have done the same. Then we have declared a double type in which 10 of our doubles are stored, and then we have applied a for loop. The first for loop is applied in a sense that it will store port C values and it will run from 0 to 99, and again a for loop is being run in which the J value, the second value, or the port B value should run from 0 to 10.
Roll number 191016. So this was our example 7.14. Inside the main function we can see that first we have declared our headers and all these commands of define fcpu and include, and now inside our main function we have uh, set the direction of port B, pin C and port D. Inside our while function we have set a condition that if pin C and the binary value is equal to 0, port B is equal to 0xF55, else it should give us 0xAA. Now inside our Proteus, here we can see that since it is following else condition, so it is giving us 1010, that is A. I've just used 4 LEDs for that. Now towards our Arduino part, so here we can see that the first and the third LED is blinking, so it verifies our result.